Sampling. Conversion of continuous analog signal into discrete analog signal is called as sampling. What is alising? If the sampling frequency Fs is less than 2 Fm, then alising is occurred. It is given by the formula Fs greater or equal to 2 Fm. Welcome for a DSP lesson on sampling. In fact, we have been talking about alising and its effects on the signal and spectrum. Now, it is time to see how alising sounds. What we are going to do here is take a piece of music which is having a sampling frequency of 44.1 kHz. Then, this sampling frequency is reduced step by step, that is, from 44.1 kHz to 22.05 kHz, again to 11.025 kHz, and so on. Then we are going to see how two cases will occur. We have two cases. In case 1, we are going to play the piece of music with reduced sampling frequency which contains alising. And in case 2, we are going to play the same frequency with reduced sampling frequency, but we will use an antialsing filter. Now let's get started with the demo. This is how the music sounds at Fs equals to 44.1 kHz, and this is the normal frequency it is played at. Now, when this is reduced by half, it becomes Fs equals to 22.05 kHz, and this is how the music piece sounds. When the original 44.1 kHz frequency is reduced to 22.05 kHz, it is not so much varied, and this is how we can listen to it. When the same 22.05 kHz is reduced to again half, it is not reduced, but it is played by using an anti-aliasing filter, and this is how it sounds. This is how this frequency is played using an anti-aliasing filter, and this is how it sounds. When the same Fs equals to 22.05 kHz is reduced again to 11.0.25 kHz, this is how the piece of music sounds. We can see clearly what is the effect of the music after playing at Fs equals to 11.025 kHz. Now, the same frequency, that is 11.025 kHz, is played with an anti-aliasing filter. Now let's see how this sounds. In this case, we can see how the anti-aliasing filter has helped to remove the aliasing effect, and this is how it was played at 11.025 kHz. Again, when this frequency is again reduced, and now when we play it at Fs equals to 5.512 kHz, this is how it is sounded. This is how the sound is played at Fs equals to 5.512 kHz. When the same FS is played with an anti-aliasing filter, we can see the effect changes, and this is how it sounds. This is how an anti-aliasing filter has helped us reduce the aliasing effect, and this is how it sounded at Fs equals to 5.512 kHz. Again, when we play the same music with Fs equals to 4.41 kHz, this is how the music sounds. Now, this is a stage where we can see how the aliasing effect affects this particular frequency, that is Fs equals to 44.41 kHz. Now, the same frequency is played using an anti-aliasing filter. This is how, at a certain stage, when it was played at 4.41 kilohertz using an aliasing effect, it was played. And when we played the same music with an anti-aliasing filter, this is how it sounded. Now, when we play the same with Fs equals to 2.12 kilohertz, this is how it sounds. This is the variation at Fs equals to 2.12 kHz. Now, if the same Fs is played with an anti-aliasing filter, this is how the music is sound. This is how it is sounded using an anti-aliasing filter. Now, at Fs equals to 1.11 kHz, this is a stage where an aliasing effect occurs with a variation, and this is how it sounds. This is how it sounds at a certain stage at Fs equals to 1.11 kHz. Now, if the same Fs is played with an anti-aliasing filter, this is how it sounds. We can see at Fs equals to 1.11 kHz, there are no changes either if we use an aliasing effect or an anti-aliasing filter, and this is how it sounds.